Hi, my name's Andy Elliott from HVA Factory, and I wanted to talk to you tonight about the process we've been through to create the clutch covers that we make. The clutch cover was designed in 1976, and this is one of the original prototypes on an original prototype bike. A few years later, Håkan Karlqvist was world champion using these engines, and they went on to produce this, which was the production part. Obviously these are in very short supply. This is one of the very last to survive, and it's an original straight from the die. You can see it's not even been drilled off, so it was a great one to begin the process of creating a fully three-dimensional solid model using scan data and an old drawing to create a model from which we were able to produce a rapid prototype. So this is a polymer part made from the 3D model, and we've made some changes to the original to improve the strength in certain areas around the kickstart, but we're actually able to fit this to a bike and with a kickstart shaft and everything else. So we're confident of being able to take this and move forward to the next process. Of course, at the same time we were able to create the liquid cooled, in fact we would have one, didn't we? So George, just grab a liquid cooled clutch cover.
Where is LC?
Yeah.
That looks like an old one.
Yeah, best get a new one out of a new box.
That's not like a late. That's like an old.
Yeah, it'll be version 7 probably.
Oh yeah, version VI, whatever that is. You want a version 7 one?
Version 7, version 8, LC.
Yeah, that's more like it.
So at the same time as making the 3D model for the air-cooled bike, we were also able to take that and adapt it to produce the model for the liquid-cooled bike. So the next part of the process was to create from the 3D model the sand casting box. So the model had the holes closed and there was a scale factor applied to allow for shrinkage of the aluminium in the die, and then a mold box was created into which the foundry press some special sand which is chemically bonded, so it sets, and then the two halves of the sand mold are brought together. Molten aluminium is poured at about 750 degrees and then left to cool. The solidified alloy is broken out of the sand using vibration, so they break up the sand around it to uncover the aluminium casting. The parts are then inspected and taken for heat treatment prior to machining. On the 5-axis CNC machine, we use a specially made vacuum fixture which holds the part upside down in order to skim the face to create a datum, and then in go all of the holes for fixing the part down when we turn it over. and then do finish machining with the oil filler hole, vent hole, obviously the two kickstart stop holes, and the reaming of the kickstart and gear lever holes prior to fitting Teflon bushes, and then a final inspection and a test to make sure everything is good before packing the parts in order that you can buy them. Well, nobody said it would be easy, and there's a lot of work involved, and the reason we've gone down the casting route is purely the efficiency of the process, in that there's very little waste. Any scrap ones can go straight back into being melted down, and the machining time is way less than a CNC from solid casing, which obviously we've considered they're on the CNC machine too long. Anyway, hope you've enjoyed finding out a bit more about how this stuff comes together, and see you next time.